In this video, we would learn how to solve system of linear equations in 3 variables using elimination. So the 3 variable systems require many more steps in order to solve, but the same concepts from solving 2 variable systems are used. So all I have to do is just pair equations to eliminate one variable, and then we solve the new system. So we're given here 3 equations. Now we can pair 2 equations. Let's say we pair equations 1 and 2. Okay, this one, and then 2 and 3, and then we solve the new system after eliminating one variable. Okay, so let's do this. So we have, let's pair equations. Okay, equations 1 and 2. So we have negative x minus 5y minus 5z equals negative 2. 4x minus 5y plus 4z equals 19. Okay, we want to eliminate z. Since the coefficients of z in the first and second equations are not equal, are not equal, so we cannot eliminate them directly. That means we have to multiply each equation by a certain number to make them equal. So we can multiply the first equation by 4 and the second equation by 5. Okay, and then these equations would become negative 4x. Okay, 4 times this one, the whole equation. Negative 4x minus 20y minus 20z equals 8. And then the second equation would become 20x minus 25y plus 20z equals 95. And now we can add up the 2 equations to eliminate z. So this is negative 4x plus 20x is 16x. Negative 20y plus negative 25y, this is 45y. Then negative 20z plus 20z is just 0. And then 8 plus 25 is 103. So this equation that we get from here is our 4th equation. Now let's pair equations 2 and 3. Okay, equations 2 and 3. Okay, so that is 4x. Give me that. 4x minus 5y plus 4z equals 19, and then x plus 5y minus z equals 20. Now we eliminate the same variable. So we eliminated z in the first step we did. So we need to eliminate z here too. Since the coefficients of z here in our second and third equations are not equal, so we need to multiply both equations by a certain number. Okay, or in this case we can multiply the third equation by 4. Okay, so let's just copy the second equation, that is 4x minus 5y plus 4z equals 19. And then the third equation would become 4x plus 20y minus 4z equals negative 80. And now we can add up the two equations. It will be 4x plus 4x, that is 8x. Negative 5y plus 20y is plus 15y. And this is 0 equals negative 61. So this is our fifth equation. And now we can solve the new system. So we can pair equations 4 and 5 to solve for x and y first. Okay. So we have equation 4, which is 16x minus 45y equals 103. And then equation 5, which is 8x plus 15y equals negative 61. So this is equation 4 and this is equation 5. And now we can solve for x and y. It's easier to eliminate x here, so we can multiply the fifth equation by 2. So let's multiply this. Say, so this is equation 4, equation 5. So let's multiply equation 5 by 2. Okay, let's just copy this. This would become 16x 45y equals 103. Okay, the fifth equation would become 16x plus 30y equals negative this is 61. Sorry, this is 61. So this is negative 122. Okay. We can subtract them, or you can just multiply the fifth equation by negative 2 and you can add them up. Okay, so we can subtract the two equations. This is 0, and then negative 45 plus 30. This is negative 45 minus 30. This is negative 75y. And then 103 minus negative 122. This is 225. Okay. And we have negative 75y equals 225. We divide both sides by 75, negative 75. So y is just equal to negative 3. So this is our y. And now we can solve for x. We can choose from either of these two equations to solve for x. Okay, so we can use the first equation, that is 16x minus 45y equals 103. So we can plug in the value of y here to solve for x. So 16x minus 45 times negative 3 equals 103. So 45 times 3 is 135. Negative times negative is positive. So 16x plus 135 equals 103. Okay, then 16x equals 103 minus 135. So this is negative 32. And we divide both sides by 16. Therefore, x is just equal to negative 2. Okay. And now we can solve for z. We can choose either of the three equations that we originally solved. Okay, the given three equations, so we can choose either of these three. So let's choose the first one to solve for z. Okay, so our x is equal to -2, our y is equal to -3, and now we solve for z. So using equation 1 from the original given linear equations, we solve for z. So all we have to do is just plug in or substitute the values of x and y that we obtained from the new system. Okay, so that is the negative of -2 minus 5 times -3 minus 5z equals 2. So this is 2 plus 15 minus 5z equals 2. 2 plus 15 is 17. Minus 5z equals 2. So -5z equals 2 minus 17. So that is 15. Okay, so this is -15, and you divide both sides by -5. Therefore, z is equal to 3. So the values of x, y, and z are -2, -3, and 3.